again, this is related rates, and the big challenge here is there is no procedure. Every time you read a problem, you have to develop the formulas, develop the situation, and then differentiate. So oil spilling from a ruptured tank spreads in a circle on the surface of the ocean. The radius of the spill increases at a rate of 5 meters per minute. This is how you know it's related rate as time. Then how fast is the area of the spill increasing when the radius is 6? If I'm on a test, this would be an easy problem. So you got a tanker, it springs a leak. We can argue about how this is not realistic, how as the tank emptied, the dV/dt would change, all right? And that you can't really have a constant dR/dt, but they did give us dR/dt right here. And that's 5 meters per minute. And they said it's in the area of a circle. So we know that form of a circle is A equals pi r squared, and it is spilling in a circle. They want to know the radius is 6, okay, but we don't include the 6 in the figure because it's changing, and so is the area. Finally, it says how fast is the area. So they are looking for dA/dt when the radius is 6. So now we have A equals pi r squared, dR/dt, dA/dt. You should be able to see those will be the derivatives. So let's differentiate. This would be the next step on most of my test stuff. It would be to write this formula that you understand how to do implicit differentiation. And now it's simply plug and chug. Get me an answer. If I do that, and I plug in purple. If I plug in what I know dA/dt then is going to be 2 pi, and I'm going to keep units, 6 meters. I know dR/dt is 5 meters per minute. I'm feeling pretty good about my answer right now. So I get dA/dt equals 30 times, I get 60 pi. And because the units are working out, I feel like I got the right answer. It's increasing by 60 pi meters squared per minute. And this has all the things. We get to show the formula, differentiate the formula, show the knowns and unknowns. Let's pause and bring up another one. All right, number 2. Crowd gathers around a movie star forming a circle. Here's my rock star. There's my circle of radius r. The radius of the crowd increases at a rate of 5 feet per second. Guys, that means that's dR/dt. How fast is the area changing? So they want dA/dt when the radius is 3 feet. Guys, this is, again, what I would call a slam dunk related rate because it is simply A equals pi r squared. It only has 2 variables. You already know dR/dt. You're looking for dA/dt. We differentiate, and again, implicit differentiation divided by dt. It's really plug and chug. 2 pi, 3 feet times 5 feet per second. And we get dA/dt to be 15 times 2, 30 pi feet squared per second. Pretty straightforward. Only 2 variables, right? A fairly straightforward problem. Let's try one that's a little more complicated. All right, so a hypothetical cube grows, so the length and size are increasing at 2 meters per minute. How fast is the volume of the cube increasing when the sides are 5 meters each? First of all, you have to know definitions. I would actually draw a little cube. And I know the sides are changing, so I would call all the sides L. You could call them X. You could call them anything you want. And I know that when I read this problem, that the rate of a side, dL/dt, is 2 meters per minute. That is unbelievable, by the way. I mean, that's growing 6 feet a minute. I mean, wow. How fast is the volume? So how fast is the volume is dV/dt when the sides are 5 meters? All right. I always teach when you have a prism, volume equals area of the base times the height. Our base is a square. So the area of that red square is L squared. L squared times L, volume of a cube is L cubed. That's the formula you got to have. Again, a lot of times it's not the calculus on related rates that trips us, it's the geometry and the algebra too. So I see I have dl dt, dv dt, I have v and l related. I don't have to work at getting it to one variable. Again, very simple related rates work this way. So I take the derivative in red. I get dv dt, or 1 dv dt, right? The derivative of v is 1. On the other side, derivative of L cubed is 3L squared, dl dt. And everybody, it's all knowns again. So it's really plug and play. So I get dv dt equals 3 times, they said when the sides are 5 meters squared times 2 meters per minute. Again, I feel pretty good about the units here. You probably can see that we're going to end up with meters squared times meters. So when I'm done, right now I can tell that my units are going to be meters cubed per minute, which is volume per minute, which is dv dt. So I'm pretty sure I've done this right, as long as I don't make a math mistake. 25 times 3 is 75, times 2, I get 150 cubic meters per minute is the change in volume. Everyone, to put that in perspective, holy crap, that's a dump truck is about 10 cubic meters. So you are bringing 15 dump trucks worth of volume to this cube right now, the way it's growing. It is a problem that I can't even picture, all right? It is a huge amount. So, but again, that's what it says. All right, I'm going to do the other two problems as a different video. Keep practicing. Related rates take a lot of practice.